super cool. All right, so today we are starting chapter 1. Our first lesson is on variables. Our objective is listed here at the top: to simplify numerical expressions and evaluate algebraic expressions. So make sure you get that filled in on your notes, and then copy down the warm-up problems and get started on those as well. Let's do these warm-up problems. I'm hoping these ones aren't too awful, at least the first couple. Number 1, 9 divided by 9. 1. Very good. Any number divided by itself equals 1. 44 divided by 11. 4. Good job. We're on a roll. 20 divided by 22. That one's a little trickier. My suggestion is to write it as a fraction. Right? Fractions and division problems can be written and rewritten interchangeably. And then all we have to do is simplify that fraction, and that would be our answer. Okay, so I know that both of those are even numbers, so they can both be divided by 2, top and bottom. If I divide the top by 2, I get 10. If I divide the bottom by 2, I get 11. And then that fraction can't be reduced anymore, so that's my answer. 10 over 11. 10 elevenths. All right, number 4 should be easy, but the way it's written might be a little strange. Did anybody get the answer for number 4? 1. I like the answer 1. I like it because when we multiply with fractions, first of all, we like them to both be fractions, right? So I could put 7 over 1, so they're both fractions. And then either you could just go ahead and solve it. When we multiply fractions, we multiply straight across. 7 times 1 is 7. 1 times 7 is 7. And we know that that reduces to just be 1. The other way you can do it would be to cross cancel. Right? The 7s and the 7s are cross reduce. We both reduce down, so it would just be 1 over 1 times 1 over 1. Either way you do it is fine with me, as long as you get the correct answer of 1. If you were to leave it as 1 over 1, that would be okay. That's fine. So on number 5, we should be able to apply a similar method of solving. We put this over 1. And I notice the numerator over here and the denominator on the other one, they're the same, so they can cross cancel. They both turn into 1s. So now, really all we have is 1 times 5,678, and we know that anything times 1 is itself. So 5,678 would be the answer. All right, so here is the start of our notes. I don't think any of this information will be brand new, but if it is, let me know. We can talk about it more. A variable is a symbol used to represent one or more numbers. The numbers are called the values of the variable. An expression that contains a variable is called a variable expression. An expression that names a particular number is called a numerical expression. A numerical expression. The number named by a numerical expression is called the value of the expression. To show that these two expressions have the same value, use an equals sign. In case we forgot what an equal sign looks like. All right, we've got the substitution principle. Again, something you've used before, I'm sure. An expression may be replaced by another expression that has the same value. So this is what we do when we plug something in, right? Let's substitute something in. If they have the same value, we can replace one with the other. Replacing a numerical expression by the simplest name for its value is called simplifying the expression. Simplifying the expression. So this isn't an example you have to copy down necessarily, but that would be like if I were to write, well, whatever, on the first slide when we did 9 divided by 9, right? We replaced it with 1. We simplified it, right? That's that idea. It's just more words. So don't let that scare you. It's something you've done before. Simplify. So we're going to replace expressions with simpler expressions. When we do that, a friendly reminder that we have to pay attention to our order of operations. Do we remember seeing this? Please excuse my dear Aunt Sally. PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. I hope that's not new to anybody. We'll be working with it more, I think, later this week. Okay, so for today, number 1, what's the first expression I can simplify? Keon.
Division.
The division. It's inside those parentheses, plus it's division. So either way, it's going to come before addition. So I'm going to replace the 4 divided by 2 with what? A 2, because that's what 4 divided by 2 equals. When I do this, I'm going to model how I want you to do your problems. We just do one step at a time. Right? We didn't change anything about the 12 plus. We're just replacing 4 divided by 2 with what it equals. Last step, we've just got some addition to do, so what's the answer? 14. Good job. That's it. There's our answer. All right, number 2, we've got the same numbers, but just a slightly different problem. What's the first thing I should do here? First thing I should replace? Keon again. The addition, because it's in the parentheses. So we need to replace the 4 plus 2. 4 plus 2 gets replaced with a 6. Everything else stays the same. All right, I heard some eager students shouting out the answer already. 12 divided by 6 is 2. Okay, I'm doing the problems this way because this is how I want to see you do your problems. Even if they're super easy, just one thing at a time. All right, on this one, if you were to do both your sets of parentheses at the same time, I would be okay with that because they're both parentheses. So in my first set of parentheses, what can I replace that with? 5. The division sign stays. And my other set of parentheses gets replaced with also a 5. 6 minus 1 is also 5. 5 divided by 5 can be replaced with a 1. Wonderful. All right, on number 4, again, we start in our parentheses, so I know the first part of my problem doesn't change. What can I replace those parentheses with? A 10. 12 minus 2 is 10. 12 times 10 is 120. Good job. All right, one step at a time, replacing things with something that's equal to it. That's how we simplify. Replacing each variable in a variable expression by a given value, and simplifying is called evaluating the expression. Okay, so before we were just simplifying. We didn't have anything with variables. Once we bring in variables and we start plugging in values and then simplifying, we then call it evaluating. More steps. Simplifying and evaluating. They're very similar, but they are two different processes. So we have values for our two variables, and we are going to plug those in to these expressions. Okay, so in example 5, the first step we're going to take is to rewrite the whole thing, but instead of an n, we're going to write a 2. And yes, I want to see this step when you do these problems. Now it looks a lot like the problems we were solving above when we were just simplifying. So we substitute, then we simplify. That's what evaluating is. All right, the first thing we will replace now would be the parentheses. Always start with parentheses. 2 plus 4 can get replaced with what? A 6. Everything else stays the same, the 3 and the multiplication sign. 3 times 6 is 18. That is our answer. So when we evaluate, our first step is to substitute, and then we simplify. On number 6, I want you guys to be careful on this one when you substitute. Remember on the first one I said, rewrite the whole thing, replacing your variables with their values. If I do this here, is that really supposed to be a 12? No, it's not supposed to be a 12. What's it supposed to be? 1 times 2. So either put the multiplication symbol in there. Another way of doing it is to put them both in parentheses. Right? Either way, don't just write it as a 12. That's a common mistake. Get rid of that. Okay, but we know we need to start inside the parentheses. 1 times 2 is 2. We rewrite everything else that did not change. And 2 plus 4 is 6. Same steps as before. We're going to substitute and then simplify. So instead of m, I'm going to write 1 plus Good. I heard someone say 14 times 2. Remember, we don't want 142. We want 14 times 2. Just like we've been doing, we start in our parentheses. 14 times 2 is 28. Everything else stays the same. 1 plus 28 is 29. Good job. Remember, I showed these steps because I expect you to do the same. On your notebook quiz, if you were to have a question that said, copy down example 7, and all you did was copy down the first line in 29, you're not getting your points. Example 7 includes all of this. Does that make sense? Hopefully it does. Okay. All right, we'll go on to number 8. Again, I'll rewrite it by substituting. 1 plus 14 divided by 5 plus 2 plus 14 divided by 4. I might run myself out of room here if I'm not careful. All right, so again, we can substitute or replace our parentheses first, and we can do both parentheses at the same time. That's okay. 1 plus 14 is 15 over 5 plus 2 plus 14, 16, still over 4. I'm going to start working out sideways here so I don't run out of space. Remember that fractions can be treated like division problems. Sometimes that gets lost and people are like, I've got a fraction, I don't know what to do. Treat it like a division problem. What's 15 divided by 5? 3. What's 16 divided by 4? 4. Okay. Then the fractions are gone and we've got a really easy problem. What's 3 plus 4? 7. Circle my answers. We are going to evaluate the expressions for the given values of the variables, just like we were doing before, but now these ones have specific applications. So the area of a rectangle can be found by taking the length times the width. We're given a length and a width. So we're going to plug those in. Again, we don't want... Sorry about that. I have to turn my pen on to write. We don't want 224. We want 22 times 4 when we plug those in. And 22 times 4 would give us 88. As always, I do want to see the step where you plug them in, even if it's a one-step problem after that. We also have the formula for the perimeter of a rectangle, 2 times the length plus 2 times the width. Again, I'm just going to plug in the values that they give me and solve like we were doing before. 2 times the length plus 2 times the width. Something to note here is that people often see a problem like this and I say, what's the first thing you should do? And people tell me parentheses, which isn't awful to say, but is there anything to do inside those parentheses? We look inside here. Is there anything to do inside? Or inside here? No, those are just numbers. Okay, so in this case, the parentheses mean what operation to me? Multiplication. Okay, so that's what I want to start with. I don't have any exponents, so we go on to multiplication. And you can do both of your multiplications at the same time. 50 plus 24. 50 plus 24 gives me 74. And of course, if they'd given me units on either of these, I would want to include those units. But they didn't, so we're fine.